properties are what you are going to want to really know for today and for tomorrow or for Thursday when we look at solving equations. So if you have, remember, if you have a plus sign, that brings together using times. You can see the plus means that we times m and n, minus means you divide, and then if you have a number in front, it becomes a power. When you're combining, think of that as like you're simplifying. When you're combining, use the power property first. Think like PEMDAS, parentheses, now think power. Power goes first. We got to the end here. This was the combining section. We're going to continue with expanding. When you have all these logs together and you have to work backwards, typically you're going to use the power property last. Think like you're solving if you're solving with an equal sign, you kind of go reverse PEMDAS order, you undo addition, subtraction. In this case, yeah, you're going to undo the multiplication before you undo the power. You do have to know when you combine, use the power property first. When you expand, you use it last. This is the power property. I would even just write this off to the side. When you combine, you use the power property first. When you expand, you use it last. I used to teach Algebra 2 with Mr. Felinsky, and he came up with the acronyms, what is that called when you like, what is it, the acronym? He said CFEL. He had students remember Coach Felinsky eats liver. I don't know if he actually eats liver or where that came from, but I remember being like a first year teacher and saying, oh, that will help students remember. And so we use that, CFEL. You can think of any memory tool you want, but you have to know that when you combine, use it first. When you expand, use it last. Speaking of, letter A, we're expanding. Do you see the power property at all? Do you see a power? The 3. So we're going to take care of this last. So now we have to think, how do we separate it? The 4 has been multiplied by the x and by the y cubed. How do you separate those out? Am I going to use a plus sign between logs or a minus sign? Yeah, plus. If we go back to that property, when 2 pieces have been multiplied, we're going kind of backwards now. We're going to put a plus sign in between those. So I'm going to go ahead and separate those with plus signs. So I would have log base 7 of 4 plus log base 7 of x. How am I going to separate x times y cubed? With a minus sign or a plus sign? So whenever you see times, you're going to plus it. Whenever you see times, because we're separating it out. So this is what we're doing. We're taking that property and we're working backwards. Log of m plus log of n. And I know this feels a little disjointed because we kind of stopped yesterday. Juliana. Oh, because if you have a base 7, that means all the logs that you were working with had to have a base of 7. So as I keep working through this next one will have a base of 7 as well. Good question. From here, what do you guys think we would do to finish the problem? Just bring the 3 in front. So use that power property last. So that'll be log base 7 of 4 plus log base 7 of x plus 3 times log base 7 of y. And that would be our answer. Basically, we're just going backwards. Yesterday, we took all these, we went forwards. Today, we're working backwards. Okay, let's go to letter B. Letter B. This one is a divide sign. You want to think back to the rule that if you had log of m divided by n, yes, that was subtraction, log of m minus log of n. So let's keep 15x together for the moment. And then that would be log base 8, it's always the same base as what you started with. So log base 8 of 15 times x. I like the division ones because that's really easy to just transfer to subtraction. That little bar kind of reminds me of the minus. They were with you for a while, huh? They still couldn't by the end? Oh, I'm sorry. Okay, so we have minus log base 8 of y. Now I'm almost done, but I see this 15 times x. Look back at this one. How am I going to separate the 15 and the x? Yeah, add. So it'd be log base 8 of 15 plus log base 8 of x. And then I have minus log base 8 of y. Okay. Before we move on to the next one, I want to remind you guys of something. You actually have the power property here. It's a little bit hidden in disguise. Do you guys remember? This is good review for the final as well. If I had like the square root of x, do you remember how I could write that as x to a power? So in fact, I'll add a 1 right here.
Oh, the 2 is the power.
The 2, it goes in the bottom of the fraction. You guys remember that? And what goes in the top? Close, the 1. So if you see a square root, that actually is a power. Some people get really tripped up by this. Just as soon as you see the square root, convert that. So if I'm looking at this, I'm going to rewrite this as a power. This would be log of 6 times. You don't see the times there. If you want to put the times in, you can. You guys have been in algebra long enough. You know if the numbers are next to each other, it means times. But that's important for the product property. So I have 6 times, and then I'm going to take 3x and look at the fact that that's raised to the 1/2 power. Now, my recommendation to you is get rid of those parentheses. Well, to get rid of the parentheses, what do I do with this exponent? Right now I have 3 to the 1st raised to the 1/2 and x raised to the 1/2. Distribute, you multiply that in. So this is actually log of 6 times 3 to the 1/2 times x to the 1/2. Chase. Good question. So I see the square root. This is review from first semester, I think, or maybe the beginning of second semester. If you have a square root, it's a power in disguise because x to the 1/2 is the same as the square root. Do you remember the number in the indentation of the radical goes in the bottom of the fraction? Yeah, we learned it last semester, I think. Or like, so let's see if you could just really quickly learn it now. Let's say we have the cubed root of x to the 1st. Perfect. Yeah, we learned it a while ago, but it's one of those rules that just kind of come up again. Good question. So if you see a radical, that's actually a power. You want to like make it into that power, especially because with logs, the power property is one of the 3 major ones that are used. Okay, then with this times, how am I going to separate? Add. How many different logs am I going to have? 1, 2, 3. There's 3 numbers, you're going to have 3 logs. There's no base. What's the base understood to be? 10. Do I have to write it in? No, I just have to know it's there. So I could write this as log of 6 plus log of 3 to the 1/2 plus log of x to the 1/2. Okay, we've done a really good job. Is there anything else that we could finish this off with? Or that we should? Kira? Yeah. No, in fact, it might be really helpful to just write it in. 10 is the base. Good question. Okay, think about those 3 properties. We use the product. Which other one could we use here? So if you were going forward, you could multiply them back, but we're going backwards. I have the product property here. I have the quotient property here. If you have a number in front of a log, yeah, that's the power property. That one you have to raise to the exponent. So basically, I should just write this in this way. This is log of n to the mth is the same as bringing it out in front. You guys know an equation's reversible, so rather than going like forward, I'm just writing it this way. I'm going, taking the m, and I'm going to put it out in front. Does that make sense? So what would I bring out in front of the last two? The 1/2, and I just bring it out right in front of the log it's next to. So this is going to become log base 10 of 6. I don't have to write base 10, but it's good to know. Plus, bring that 1/2 right in front. Plus 1/2 times log base 10 of 3. Plus 1/2 times log base 10 of x. And that would be the final answer. All right, let's try another one. Letter D. Ooh, get rid of those parentheses. What's the invisible exponent on 3? 1. How about on x? 1. So how do we get rid of those parentheses last time? Distribute. Same thing you'll do. Just distribute that in. So this is actually log base 2 of 3 to the 4th times x to the 4th. On your own, just try it. See if you can get to the end. We can fix it if you get it wrong. I'll give you a hint. You should start by getting rid of this times. Times, you do addition. Okay, this should have been your first step. Separate the times using plus. There's one final step you should do. Take the 4's out front. So your final answer would be 4 times log base 2 of 3 plus 4 times log base 2 of x. Jace. Yes, that's important for the rules. So if we go back to the rules, they only work if all the bases are the same.
Okay.
If the other one, like if one was a log base 2 and the other one was blank, it would be a log base 10 and you couldn't use these rules. Guys, just a quick reminder from yesterday. What was this one that we did? Nope, I've already forgot where I put it. But do you guys remember we did all those like putting the things together? It's the same stuff. You just have variables that you're working with. But this is actually almost the exact same as what you guys did yesterday. First thing I would ask you for example 3, are you combining the logs into one or are you expanding? It says use the properties of logarithms to evaluate each expression. Yeah, we're going to combine them because they're already separated out. So we're combining them. When should we use the power property? Yep, if there's one out front and we want to make sure that we use it first. If you're expanding, you use it last. That's why this one at the end, I brought the 1/2 out. Okay, letter A. Letter A, I actually started this one with you guys on the whiteboard and you like almost, I think you all got it right. What do we do with that plus sign? Multiply. So it's log base 4 of 2 times 8. What's 2 times 8? 16. And then I actually started with, this is the very first one I started with you guys. I said, evaluate this. This is what this is saying. Use your properties and then evaluate. So how do I determine what the value is?
4.
Yeah, I'm saying 4 raised to what power is 16? 4 times 4 is 16. That's right. 4 times 4 is 16. So this would be 4 squared. Awesome. So that answer would be 2. How about letter B? What am I going to do with that minus sign? Divide. So we have log base 5 of 50 divided by 2, which, yep, Luke told us is 25. What's the answer to this one? 2 is correct. 5 raised to what power is 25? Again, 5 times 5 is 25. So that's 2. All right, how about the next one? What should we do first?
Divide.
I want to divide first so bad because I see that minus sign.
Bring them.
There is something in front. The 2 we have to, you guys are right, take care of first. So use that power property first. So this is actually log base 4 of 6 squared minus log base 4 of 9. What is 6 squared? 36, right? Minus log base 4 of 9. It's all good. And then the divide sign, what does that turn into when you bring them together as one? It turns into a minus sign. Turns into a divide sign. You're right. 36 divided by 9. They like look the same. That's like my easiest reminder. It's just if you write them, what is that? Horizontally, it's a minus. If you write it vertically, it's a divide. You can actually divide 36 by 9. Yeah, what is 36 divided by 9? It's 4. You're right. Now, what is this value? What's it equal to?
1.
Correct. That's my answer. Let's try this last one. A little tricky, not too bad. The minus sign, how do we bring them together? Divide, so this is log of 1 divided by 1,000. Hold on, there's no base. Good, it's 10. Write it in. And now we ask, what does this equal? This one's a little tricky, but I think you guys can do it. 10 raised to what power is 1 over 1,000?
Isn't it 4? 100.
10 to the third is 1,000. That's true. 10, I'll even write that. 10 to the third is 1,000. How do I put it under 1? Yes, make it negative. If it's a negative exponent, you just put it under 1. Another rule that we learned a while ago. A to the negative m is equal to 1 over a to the m. So what's the answer? It's -3. If you see it under 1, just make it negative. It's a negative exponent. Okay, you guys have a worksheet that I gave to you for homework. You have 18 minutes to work on it. If you finish early, bring it up. I'll check it for you. And that's it. It's all the same. Yeah, the today and yesterday.